I'm going to do that again. I'm a principal product manager on Amazon Elastic File System. Thank you so much for joining today. Given that this is reInvent and this is the 4th day of reInvent week, I'm super excited to see a packed house of audience. So thank you for spending your 1 hour with us today. I appreciate your attendance. Here is a quick list of all the EFS sessions that we have had this week. In case if you missed any of these sessions, given that if it's a breakout session, you may be able to view some of these sessions online. So please take a moment to take a photo of this so you can go and chase some of the related sessions. These sessions range from covering AWS storage solutions for containers and serverless at a 200 level, then diving deep into a 300 level, like this session in a deep dive manner, talking about introduction of Amazon EFS replication and also introduction to new EFS performance enhancements. So a lot of EFS sessions for you guys. Okay, so in this deep dive session for Amazon EFS, we're going to start with our customers, and we're going to talk about what our customers are doing. Then we will dive deep into Amazon EFS and understand what makes it a cloud-native file system. We're going to talk about security, data protection, and compliance for Amazon EFS. We're also going to be talking about how you can build scalable and elastic applications using Amazon EFS and other microservices architectures. We're going to wrap up the session with some of the recent launches that we have done as well. So I know we call this a deep dive session, but you all don't need a diving suit. What you need to do is sit back, relax, and enjoy the session. We'll make it fun. Let's go. So what are our customers doing? We see 3 major trends when it comes to what our customers are doing. The first one is they're migrating their applications, including their persistent storage, from on-premises onto AWS. Then they're modernizing their existing applications that are either running on-premises or even on AWS on EC2 instances to use microservices architectures like containers and serverless. And the third trend that we see is they're building brand new cloud-native applications using cloud-native compute and storage services. So data is, of course, key to all of these applications. And in fact, a large part of data is file data. No wonder why this session is full at this point. So as you may expect, many existing applications are file-based. So file storage is important for the migration use cases, so that is expected. But what may be less well known is that file storage cuts across all these 3 trends. It is also very important for modernizing and building cloud-native brand new applications. So we just discussed that our customers use file storage for modernizing and running their existing applications and for building and running brand new cloud-native applications. Let's take a quick look at some examples. Applications that our customers are modernizing include web and content management systems, data science, and insights. It also includes DevOps as well. Applications that our customers are building brand new using cloud-native services include machine learning and inference and machine learning analysis. We're going to dive deeper into these use cases with some specific customer examples later in the session. Okay, so implementing a self-managed file storage has its own limitations, so please don't do it. It is difficult to scale. Customers constantly have to manage operations to avoid running out of storage. This usually means they're over-provisioning their resources to anticipate peak demand. And also, procuring servers and storage can take several months. And then your agility is slowed because you are spending a lot of time in forecasting storage, and you have to get your storage team involved in your application deployment process. And then there's the administrative overhead. You need to manage and monitor infrastructure, which typically needs to be updated every 3 to 5 years. And with all of this, the total cost of ownership of a self-managed system is high. So a cloud-native, performant, and a cost-optimized file system can enable new possibilities. And that's where Amazon Elastic File System can help you accelerate your business innovation and help you hit the market faster. Let's discuss how we can do that. We launched EFS back in 2016 to give our customers a super simple, set and forget, cloud-native, elastic file system. It is cloud-native by design and by purpose. It's actually built from ground up in the cloud to be simple at cloud scale and to be fully elastic. It grows or shrinks based on customer demands, and you only pay for the capacity you use. It can elastically scale up to tens of petabytes. Scaling up to tens of petabytes is a great thing, but scaling elastically up to tens of petabytes, that's bar raising. EFS is serverless. It is infrastructure free. You don't have to think about managing and operating your storage infrastructure. This allows you to focus on accelerating your innovation and removing the need to spend cycles on the undifferentiated heavy lifting of infrastructure management. EFS is secured using cloud constructs like AWS Identity and Access Management, AWS Key Management Service, resource policies, and access points to control access to your file system and to enforce behaviors like encryption. EFS is also protected using cloud constructs like AWS backups that allows you to centrally manage your backups and schedule automatic backups. And then one really cool thing is EFS is consumable from any AWS cloud computing model at scale. Since it's natively integrated with computing models like containers, serverless, and Lambda, you can scale up to tens of thousands of connections from any of these models when you're consuming EFS. Well, there is more. EFS is cost optimized. It provides 4 storage classes at different price and performance characteristics. It comes with automatic lifecycle management to transition your infrequently accessed files to a cheaper infrequent access storage class. It also offers intelligent tiering to optimize cost for use cases that has variable access patterns. So using our one-zone storage classes, and I'll talk about that in a little bit, using our one-zone storage classes and an industry average of 20% of the files being frequently accessed and 80% being infrequently accessed, you can achieve a blended storage cost of 4.3 cents per gigabyte per month. Blended storage cost of 4.3 cents per gigabyte per month. Let's talk about performance. EFS is performant. It offers latencies as low as 1 millisecond. You heard me right. I'm talking about 1 millisecond read latencies from EFS. It can scale up to tens of gigabytes per second of throughput and can support over 500,000 IOPS. We're going to break it down in a little bit more detail shortly. Finally, an important piece, EFS is designed to be highly durable and highly available by purpose. It is designed for 11 nines of data durability and offers an availability SLA of up to 99.9%. So let's talk about the use cases. EFS is designed to serve a vast majority of file-based workloads. It covers a wide spectrum of performance needs. It ranges from single-threaded, latency-sensitive applications to highly parallelized, scale-out workloads that require high throughput, like big data applications and machine learning, and everything in between. So let's take a look at some of the use cases for Amazon EFS. The first one I'd like to talk about is simplification and centralization of DevOps, which includes continuous integration and continuous development pipelines, code repositories, and issue tracking. Common applications in this category include Jenkins, Confluence, and Git. Next, we have web serving and content management, which involves creation and modification of digital web content. Common examples or common applications in this category includes WordPress, Drupal, and Moodle. Then we have the data science and analytics. EFS enables customers to accelerate their data insights, machine learning inference, and analysis. Tools like Airflow, TensorFlow, and Informatica are commonly used in this category. Then we've got media processing, which includes image processing and video hosting. The fifth use case is very cool too. Since EFS is highly durable and highly available, it is also used as a backup destination for holding backups of databases like Oracle, Cassandra, and MongoDB. Last and definitely not the least, EFS is used in modern application development. It allows customers to obviously build cloud-native applications, but it also helps customers to migrate their existing custom enterprise applications by lifting and shifting directly onto EFS. And once they're on EFS, you can modernize them at your own pace. Okay, so it's time to dive deeper into Amazon EFS and break all of these specific capabilities down further. So we're going to start with cost optimization. And to talk about cost optimization, it's important to understand storage classes for Amazon EFS. EFS has 4 storage classes, and they work in pairs. We've got 2 one-zone storage classes, EFS one-zone and EFS one-zone IA, and we've got 2 standard storage classes, EFS standard and EFS standard IA storage classes. Now, both one-zone and standard storage classes are highly available and designed to be highly durable. One-zone storage classes are low cost and low latency, and standard storage classes are regional. They are multi-AZ. There are differences between these storage classes. Let's find out what they are. One-zone storage classes redundantly store data within a single availability zone and are designed for 11 nines of durability. Now, our standard storage classes redundantly store data within a single and multiple availability zones, and they're also designed for 11 nines of durability. While one-zone storage classes offer an availability SLA of 99.9%, that's 3 nines, our standard storage classes offer an availability SLA of 99.99%. That's 4 nines. So that's one difference between the 2 classes. Now, with the blended storage cost of 4.3 cents per gigabyte per month, one-zone storage classes are 47% lower cost than standard storage classes, which has a blended storage cost of 8 cents per gigabyte per month. Now let's talk about latencies. From a file operation latency point of view, both one-zone and standard storage classes have read latencies as low as 1 millisecond. But for one-zone storage classes, since data is stored within a single AZ, they offer write latencies as low as 2.4 milliseconds, which is 35% lower compared to our standard storage classes, which has a write latency of 3.6 milliseconds. So I want to build up on cost optimization. With EFS, like I've said, your effective storage price is just 4.3 cents per gigabyte per month for one-zone storage classes, and 8 cents per gigabyte per month for standard storage classes. And at this price, you get all the fully managed features of EFS right out of the box. So how does this all work? Well, the key is lifecycle management, which monitors your workloads and file access patterns and automatically saves you money by moving your files that are not accessed frequently from our standard storage classes or one-zone storage classes to the respective infrequent access storage classes. And if we use the 80-20 rule of 20% files being frequently accessed and 80% not, you can achieve 4.3 cents per gigabyte per month for one zone and 8 cents per gigabyte per month for standard storage classes from a blended cost point of view. We also have intelligent tiering. Earlier this year, on AWS Storage Day, we launched EFS Intelligent Tiering to optimize your storage costs for workloads with unknown or changing access patterns. See, lifecycle management moves your data from frequent storage classes to infrequent storage classes. But intelligent tiering can promote that data back to frequent storage classes, depending on your workload access patterns. It puts your file in the right storage at the right time. So when you use EFS Intelligent Tiering to move files between frequent and infrequent access storage classes, you're provided a cost guardrail from access charges. Let's talk about some of the use cases of EFS Intelligent Tiering. Any workload can actually benefit from EFS Intelligent Tiering, but workloads where data access patterns are unpredictable will benefit the most. So these workloads includes data science and analytics. We talked about that as one of the use cases of EFS. We talked about modern applications running on containers and Lambda, where concurrent access to a set of files is very common. Then we have user-generated content that tend to go up or down based on the usage of time. Web content management is a good example of that. And then we've got financial simulations. These type of workloads with variable access patterns can benefit significantly from EFS Intelligent Tiering. So let's summarize cost optimization. You can significantly lower your total cost of ownership with Amazon EFS. There are many reasons for this. There is no minimum commitment or fees. You only pay for what you use. It is infrastructure free. You don't need to provision or manage any infrastructure ahead of time. And you can scale elastically and instantly up to tens of petabytes. It is optimized to be consumed by any AWS compute model at scale. But the multi-AZ architecture of EFS storage classes enables the compute to access EFS classes cross-AZ without any charges, without worrying about charges. Then we talked about EFS intelligent tiering that automatically places your file in the right storage at the right time, and lifecycle management moves your file to the lower cost infrequent access storage classes. And then we talked about one-zone storage classes that offer 47% lower cost compared to our standard storage classes. Now, if you sum it all up, and if you do the total cost of ownership analysis, comparing this to running your own file system, you will find that EFS is 90% more cost-effective than doing it yourself. So please do not do it yourself. Okay, we're going to talk about performance next. With EFS, you can expect read latencies as low as 1 millisecond. You can drive up to 500,000 IOPS and 10 gigabytes per second throughput. Let's dive deeper and understand how this works. And for that, we need to understand EFS's performance modes. Amazon EFS has two different performance modes that you can choose from. The default performance mode is general purpose mode. This is what we recommend for the majority of workloads. As you test your applications with Amazon EFS, we recommend that you start with general purpose performance mode. The other performance mode is max IO. This is intended for scale-out workloads. So let's do a compare and contrast of these two performance modes. We're going to start with what they're designed for. General purpose performance mode is intended for general purpose workloads, and also workloads that are latency sensitive. Max IO performance mode, on the other hand, is best for scale-out workloads with data-intensive applications. So each performance mode has their own advantages and their trade-offs. For example, with general purpose performance modes, you have the lowest latencies for file operations. Read latencies as low as 1 milliseconds. But it comes at a 35,000 read IOPS and 7,000 write IOPS limit. On the other hand, with max IO performance mode, you virtually have unlimited ability to drive IOPS and throughput. You can go up to 500,000 IOPS. You can go up to tens of petabytes of throughput as well, tens of gigabytes of throughput as well. However, our max IO performance mode has slightly higher latencies compared to our general purpose performance modes. So as I mentioned before, we recommend if you're testing EFS, you start with general purpose performance mode as it is the best choice for most workloads. If you have a data-intensive application, then we would recommend using a max IO performance mode. The other facet of performance that we want to understand is throughput. So EFS offers two different types of throughput modes. First is the bursting throughput mode. This is the default throughput mode, and it's also the recommended throughput mode for majority of workloads. With bursting throughput, your throughput scales automatically with the size of your file system. You're able to drive 50 megabytes per second of throughput per terabyte of data stored in your file system. And additionally, you are then able to burst to double that and drive 100 megabytes per second per terabyte of data. And that's what bursting is all about. Second, we have provision throughput. With provision throughput, you set the throughput independent of the storage of the file system. So let's do a compare and contrast of the two throughput modes. We're going to start again with what they're designed for. Bursting throughput mode is good for workloads with variable throughput demands. Bursting throughputs allow you to burst to higher levels of throughputs, double your baseline for short periods of time. And then we've got provision throughput, which is best for workloads that require consistent high throughput. So they have their advantages and they have their trade-offs. For example, with bursting throughput, you are scaling automatically as your file system grows. However, the trade-off is you're also dependent on the size of the file system. And with provision throughput mode, you define the throughput that you want, but the trade-off is that you're charged separately for storage and throughput. So as mentioned before, bursting throughput is the default throughput mode. As many workloads are spiky in nature, we recommend that you should start with bursting throughput mode and take advantage of the bursting that you get with higher throughput. Use provision throughput if you know that you need higher levels of consistent throughput. For example, when you're ingesting a bunch of data into the file system. I want to talk about provision throughput just a little bit more. As I said, the throughput is independent of the data stored in the file system. We know that already. You can also increase the provision throughput amount as often as you like. You can start with 1 gigabytes per second, and if you want to increase that to 2 gigabytes per second, you can do that as well. But you can decrease the throughput amount or change the throughput mode only once every 24 plus hours. So that is something to keep in mind. So we talked about cost optimization, that EFS is cost optimized. We talked about performance, EFS is performant. The third facet I want to talk about is cloud native. Amazon EFS is cloud native. Let's dive deeper and understand what capabilities make EFS cloud native. So as I've mentioned previously, EFS is built from ground up to be simple at cloud scale. It is elastically scalable to tens of petabytes. It grows and shrinks based on customer demand, and you only pay for what you use. That's elastic scalability for you. Then EFS is serverless. Like I've said, it is infrastructure free. You don't have to think about managing or provisioning storage. You can focus on developing your applications and accelerating your innovation. And thirdly, EFS is highly durable and highly available, and that is inbuilt into EFS. It is designed to have 11 nines of data durability and up to 99.99% availability SLA. It is secured using cloud constructs like AWS IAM, AWS KMS, resource policies, and access points. So you can control client access, and you can enforce things like encryption. You can enforce things like squashing root access. It is protected using AWS Backup, which allows you to centralize your backup and automate your backup scheduling. And coming soon, you can use native EFS replication to replicate your file system within and across regions to meet your compliance, disaster recovery, and business continuity goals. I'm going to double click on replication shortly, but that is our announcement at re:Invent this year. So super excited about that. The last thing I want to talk about here is that EFS is consumable from any AWS cloud computing model at scale, including serverless, containers, and EC2 instances. And this is because it's natively integrated with these computing models that allows us to scale up to tens of thousands of connections that come in from these models. So obviously, we talked about a lot of EFS being cloud native. This is a deep dive session, so we're going to have to unpack this even more. So let's do that. We're going to unfold why EFS is cloud native even more by understanding how EFS is secured using constructs like AWS IAM and AWS Key Management Service. So firstly, you can control client access at multiple levels. For network traffic, you can use Amazon VPC security groups and network ACLs. And then for client authorization, you can use AWS IAM identity and resource policies. Using IAM authorization for clients, you can enforce encryption. You can provide read-only access to your file system. And you can also implement root squashing. You can control file and directory level access using standard Linux POSIX permissions. You can use access point for providing application-specific entry points to your file system and data. And then you can enforce a specific identity for those access points for any connection using that access point. So we talked about controlling client access, and we talked about controlling file and directory access. You can use AWS IAM to manage API administrative access as well, such as controlling who is allowed to create a file system and who is allowed to modify a particular file system. And then you can use tagging to do this at scale. You can encrypt your file system at rest using keys managed by AWS KMS, and you can encrypt your data in transit using the industry standard TLS 1.2. You can also enforce encryption of data in transit and enforce encryption of data at rest, depending on the compliance requirements of your organization. Lastly, EFS has been added to a list of services that are HIPAA eligible, GDPR compliant, SOC and ISO compliant, and also FedRAMP authorized. There is more we should talk about security. It's an important element. So let's talk about how you can create a multi-tenant environment using cloud-native services with Amazon EFS. So when it comes to a multi-tenant environment, there are really two fundamental goals in terms of identity and privacy when applications are accessing shared storage. The first thing is the storage needs to be accessible from a certain set of clients. That is identity. And then second, those clients need to present the proper credentials and permissions to access specific pieces of that data. That's privacy. Identity and privacy, those are the two fundamental things. So using AWS IAM, you can attach policies to your file system to govern its usage, either by restricting access to a limited set of users and clients, or by enforcing behaviors such as ensuring that encryption is enabled, providing read-only access to the file systems, or squashing any attempts to root access to the file system. And then we've got access points. Using access points, you can synchronize permissions and you can prevent privilege escalation by enforcing the identity of all incoming connections to use that access point. This is particularly useful for serverless functions where there's no first-class notion of POSIX, but it is also useful for containers where the identity of the containers is baked in at build time. And a lot of times that identity is root, which means your applications will be accessing the EFS file systems as root. And the chances are you do not want that. So access points give you a really simple mechanism for providing application-specific entry points into your file system and data. So using access point in conjunction with IAM policies, you can limit which users can access which access points and with which permissions. And you get the power and flexibility to create and manage a multi-tenant environment in a cloud-native way. Next, let's understand how EFS is protected using cloud constructs. Like I previously mentioned, EFS is natively integrated with AWS Backup. So let's unpack that a little bit and see how that works. I know some of the folks in the audience has questions about data protection for EFS, so this will be a very good part of the section to discuss all of that. So firstly, AWS Backup provides policy-based data protection and management to help you meet your data protection compliance goals. You can back up your EFS file systems using automatic tag-based scheduling. And depending on how you design your tags, if new file systems are created, they will automatically be picked up by your AWS backup policy. You can retain your backups also via a user-defined policy. You can retain your backups for longer term. If you want, you can retain your backups for years, depending on the compliance requirements of your company. You can, just like with EFS, which is cost optimized, even when you use AWS backup, you can cost optimize how you store your backups. You can lifecycle your backups from warm storage to cold storage. With AWS backup and Amazon EFS, you're able to set up cross-region backups and cross-account backups as well. You can protect your Amazon EFS file system from accidental deletion by a user or an unwanted override by an application. See, EFS is already highly available and durable, but if a user inadvertently deletes a file, EFS will delete that file. So it's important that you take AWS backup, and when you have a backup, you can go back to a previous recovery point and then recover that file from that backup. So talking about recovery, using an AWS backup recovery point, you can either restore the entire file system, or you can restore files and folders. When you're restoring your file system, you can restore to the original location, or you can create a brand new file system and restore the entire file system there. So you have some flexibility in that as well. So you can do granular restores or item level restores, and you can also do full file system level restores too. But there's more to data protection apart from AWS backup. So super, super excited to introduce Amazon EFS Replication, coming soon to your favorite region. Amazon EFS Replication automatically and transparently replicates your EFS file system data to a second file system. It is continuous. And you have the flexibility to select a destination region or availability zone of your choice. EFS Replication is designed to help you meet your business compliance, disaster recovery, and business continuity requirements by helping you achieve RPO and RTO of minutes. Yes, I'm talking about minutes. And you can do all of this and save up to 85% on your disaster recovery storage cost. How would that work? If you want to learn more about that, STG 343 is where we went deeper into how you can save 85%. But I'm going to quickly highlight that over here. So you can have your primary EFS file system. Let's say you're using standard storage classes. So with standard storage classes, you can use a lifecycle management policy of 30 days. And if you are using the industry average of 20% and 80% being infrequently accessed files, that would be your standard file system. For a 100 terabyte file system, you would pay approximately $8,192. Now, your replica does not have to be the exact same characteristics. You can set the replica independent of your primary. So in this case, you can have your replica to use our EFS one-zone storage classes instead of the standard storage classes. The one-zone storage classes are 47% less expensive, lower cost, right? And then on your replica, you can use a shorter age of policy for your lifecycle management. So instead of 30 days on your primary, you can, for example, use 7 days on your replica. And that is okay, because this is your replica file system. Chances are it's not being used heavily as your primary is. It is there for your disaster recovery compliance. It is there for some read-only access. So with one-zone storage classes, with the 7-day lifecycle management policy, and 95% of your data on your replica is expected to move to the infrequent access tier because it's not being used heavily, you will be able to save up to 85% on your storage cost. There's a lot more detail and all the numbers available in STG 343. You will be able to view it online when it's available. So super excited about Amazon EFS Replication. So I know you may be wondering at this time, Abrar, you talked about cloud constructs using AWS backup. Now you're talking about Amazon EFS Replication. Do I need to use both? Do I only need one? How does that all work? Amazon EFS Replication works alongside with AWS backup to provide you with comprehensive data protection to meet your compliance, retention, disaster recovery, and business continuity goals. Just think about it. I just added retention to the requirements. Previously, we were talking about compliance, disaster recovery, and business continuity. Retention is also included here, and that makes it comprehensive. So with Amazon EFS Replication, you can configure same region or cross-region replication for your file system. However, EFS Replication is always going to create a single recovery point. So as we sync your replica, the recovery point is always updated. The point is you will always have the latest recovery point based on when we last synced that replica. So there's only a single recovery point. It is primarily used for disaster recovery and business continuity requirements. The best part about replication, however, is you get to achieve the RPO and RTO of minutes. However, you have a single recovery point. Now, on the other hand, with AWS backup, you can configure both same region and cross-region backups. And you're able to configure multiple recovery points. You can take daily backups. You can actually also take hourly backups. That's RPO of hours. You can take hourly backups with AWS backup, and you can retain them for months and years. So you have multiple recovery points. You're able to retain them for longer term. However, with AWS backup, depending on the size of your file system, your RPO and RTO could be up to hours. So the difference is with replication, you get RPO and RTO of minutes. With backup, you get RPO and RTO of hours, but you have multiple recovery points. So the bottom line is you need to use both EFS Replication and AWS backup for comprehensive data protection to meet your compliance, your retention, your disaster recovery, and your business continuity goals. Okay, so far we talked about EFS being secured using cloud constructs. We talked about EFS being protected with cloud constructs using AWS backup and Amazon EFS replication. Next, I want to focus on EFS consumed elastically and at scale from any AWS computing model, including Fargate, Lambda, to build scalable and elastic applications. This is where we're going to look at customer use cases and specific examples as well. Many customers are migrating their existing applications from on-premises or even EC2 instances on AWS to use containers because they want to simplify their operations, they want to lower their compute cost, and they want to be able to scale more elastically. And because EFS is integrated with ECS, EKS, and Fargate, even applications that need persistent short storage can also be migrated. But why EFS? Well, we talked about a lot of these things, but I'm going to recap a few. Customers can persist storage across container instances with EFS, and they only pay for what they use. They don't have to think about infrastructure because EFS is serverless and fully managed, just like the way AWS Fargate is serverless. And then ultimately, you're able to create a multi-tenant environment in a cloud-native way using IAM authorization and access points. So let's look at this integration in action. Let's take a look at a specific customer example. Let's talk about building modern, scalable digital experiences. So in this example, we're going to talk about content management systems. That is also one of the digital experience. So content management system uses applications like WordPress and Drupal to share uploads and content across multiple instances. Content management systems require high availability, high performance, and the ability to share data across container instances, and also the ability to scale up and down based on business needs. I mean, think about you're building a website. It's the content management system. It's going to have a peak. It's going to have a valley. And you want your infrastructure, both compute and storage, to elastically go up and down with that peak and valley. So how is this all going to work? So when visitors come to the URL, they're pointed to an application load balancer that is able to spread the traffic across multiple Fargate instances that are available in multiple availability zones for resiliency. Now, since EFS storage classes are also multi-AZ and resilient, they're available in each of the multiple availability zones where Fargate instances are. So you can easily mount those EFS file systems onto those Fargate instances. So in this case, EFS is not only highly available and elastically scalable, it is also shareable. So you make an update to the EFS, and the other instances can automatically retrieve that update. And one other architecture that we're using here is Amazon Aurora Serverless to hold the relational database transactions of your content management system. So if you take a good look at this picture, every service that we're talking about here is serverless. AWS Fargate is serverless, EFS is serverless, and Amazon Aurora is also serverless. So this is a completely serverless architecture helping you build modern, digital, scalable experiences. You're able to scale elastically, and you only pay for what you use. So this was a reference architecture. Let's take a look at specific customer examples who have actually done this. Acquia modernized their web hosting services using Amazon EKS and Amazon EFS to reduce their infrastructure and operational maintenance overhead. So they got a lot of benefits out of this. They improved their customer experience by being able to dynamically scale their environments, number one. Number two, they were able to lower their total cost of ownership through improved storage and compute utilization. And number three, they reduced their administrative burden by using fully managed serverless services. Another customer example that we can look at is Johnson & Johnson. They built their data science platform using Amazon EFS and Amazon EKS. Obviously, they're now able to scale that platform elastically. They also were able to increase their innovation by reducing the data analysis time by 35%. And then lastly, they were able to reduce their storage cost by 37% by using EFS one-zone storage classes and EFS lifecycle management policy. So we talked about using EFS with containers with AWS Fargate to build scalable digital experiences. There is another important service I want to talk about, and that is AWS Lambda. Let's talk about how you can build cloud-native applications that are elastic with AWS Lambda and Amazon EFS. Our customers are building petabyte-scale, highly durable and highly available serverless applications by using EFS as a serverless shared storage layer. But why EFS again? Let's take a look at that. So number one, as we have already mentioned, EFS provides petabyte-scale elastic storage for Lambda functions. So previously, without EFS, Lambda could not operate on data larger than 512 megabytes, which is allocated in the temp space of that Lambda function. But now, with EFS, Lambda is able to consume large size of data sets. So that's one advantage. The second advantage is by saving the state of the function at the end of its processing and then loading the state at the next run, you can now make your serverless applications stateful, not stateless, stateful. And then your functions run faster because EFS provides consistent low latencies for file system operations. We talked about 1 millisecond for read latencies. And since EFS is elastic, Lambda is elastic, you're able to build a fully elastic application with compute and storage that is growing elastically. So your developers are focused on building applications and don't have to worry about managing the underlying infrastructure, including the compute infrastructure in this case. So your customers are going to be able to build scalable applications by sharing data across tens of thousands of Lambda functions. So I want to look at this in action, right? So we talked about how this works architecturally. Let's take a specific look at a customer example. So in this case, we're going to talk about how you can build an elastic machine learning inference application. Machine learning inference is one of the most common applications our customers are modernizing with AWS Lambda. So what is inference? Inference is a real-time part of machine learning. So once you use historical data to build your machine learning model, you want to use that model to classify and predict events. And that is called as inference. So with EFS, there is no size limit on how much data can be stored. So customers can use Lambda for any kind of inference, and they can use EFS to store large data sets. Without EFS, they would be limited because Lambda has the temp space. So how does it all work together? So first, your ML engineer will start by loading your ML model onto Amazon EFS. So that's step number one. And then step number two, your client application is going to make a request by posting an image. This specific image has text in Chinese language. So our inference application is going to extract the text from this image and return the text in Chinese as that predicted label. So that's the design of this application. So the user is going to post that image to an API gateway. The API gateway is going to invoke the Lambda function to serve that prediction. Now the historical model data is loaded into the Lambda function from Amazon EFS. The Lambda function uses that preloaded model to serve up the prediction and return that predicted label back to the user. So let's summarize this. Both Amazon EFS and Amazon Lambda are very attractive for inference use cases because they're both completely elastic. What does it mean? It means that you're not paying if you're not serving any prediction. And when you are serving predictions, you're only paying per prediction. Total cost of ownership savings there. So let's take a look at an actual customer example here. For SkyWatch, processing satellite images was challenging because the images did not fit in the Lambda temp space and processing time was very slow. So they use Amazon EFS to store and process their satellite images. EFS enabled them to concurrently process data through a multi-stage image processing pipeline because EFS is shareable. They were able to accelerate their image processing time because EFS provided consistent low latencies, and they were also able to lower their costs through reduced operational overhead. I've got another example for you. Asurion built an on-demand elastic machine learning inference using AWS Lambda and Amazon EFS. As a company, they offer support contracts, so customer service is a huge part of their business. They want to ensure that their customers are having a good experience when they call in. They want to make sure their operators are being nice and they're being humble to their customers. So they record the call volumes, and they use ML inference to predict those call volumes to see if the customers are having a good experience or not. Now, because the call volumes could be high or low based on a daily cycle, they wanted to use AWS Lambda to achieve elasticity and a pay-as-you-go version and reduce the total cost of ownership. But without EFS, they were not able to do this because of the temp space. So what is the benefit here? Asurion built a machine learning inference that is able to scale elastically based on the call volumes. They were able to reduce the total cost of ownership, and they reduced the operational overhead using both AWS Lambda and EFS. Their application is now running infrastructure free. So just to summarize, we talked about EFS being secured using cloud constructs. We talked about protected using cloud constructs and consumable from any AWS compute model at scale, tens of thousands of concurrent connections. So what does all of this mean for you? Like, what do you do with this? Well, you can accelerate your innovation and your business transformation with EFS. One thing that excites our customers, besides how easy it is to get started, is that EFS helps minimize their risk in this journey. Why? It's because EFS is there in every step of the way. It gives customers capabilities to migrate their applications and storage to the cloud today, and then customers can modernize their applications at their own pace. They can also build cloud-native applications using cloud-native services. EFS is there in every step of that trend. So using serverless, elastically scalable, and cloud-native capabilities of EFS results in deployment, development, and operational efficiency, which enables you to deliver more features and capabilities to your customers in a shorter amount of time. It reduces your time to market significantly, and that's how you can accelerate your business transformation. So we are approaching towards the end of the session. I do want to leave you with what are some of the recent launches that we have done for Amazon Elastic File System. In 2021, EFS continued its pace of innovation with over 15 launches. So I'd like to highlight a few key launches in this session today. In January, we launched 3x read throughput. We increased the read throughput by 3x. This allowed real-time applications like machine learning inference to handle 3x more concurrent requests and obviously complete 3x faster. In February, we launched support for EFS, consuming EFS from Amazon EC2 Mac instances. So if you're doing media processing and your clients are on a Mac instance, you can now access EFS from those Mac instances. In March, we launched our one-zone storage classes, 47% lower cost, low latency, 1 millisecond read latency, and highly available and highly durable. In April, we also added support for cost allocation tags for EFS backup. So if you're using AWS backup for EFS, and if you want to manage the cost, you can now use the cost allocation tags. In September, we launched EFS Intelligent Tiering, allowing customers to achieve the right price and performance plan by automatically placing the file in the appropriate storage class. So from a call to action point of view, if you're new to EFS, if you have not already created a file system, I invite you to go create it. It's super easy. You can create your file system in seconds in as little as 2 clicks. And if you're already an AWS customer, Amazon EFS is free to get started. I quickly want to show all of these sessions again. If you have not taken a picture, please take a look at it, but we have a lot of sessions from 200 level to 300 level, also up to 400 level. Thank you so much for your time and attendance today. I really, really appreciate you guys joining me. Thank you. We do have 10 minutes, though. We do have 10 minutes. If we want to do a live Q&A, I'm happy to do that. I'm also happy to do an offline Q&A. So the floor is yours. Please let me know if there are any questions. Please go ahead.
In regards to replication, because I went to a session earlier on the US3 with the RPC and multi-way replication. Is that coming to EFS?
Could you repeat the question one more time, please?
I went to a session on S3 and they introduced some new features, multi-way replication,
Uh-huh.
and I think it was RTC.
Uh-huh.
They had the SLA
Got it.
for that.
Got it. So just me repeat the question. The question is, do you have plans to support multi-direction replication with Amazon EFS at a high level, right? So the coming soon version for Amazon EFS replication is going to support a unidirectional replication. So you're going to have a source and you're going to have a target. But obviously, our roadmap is driven by what our customers say, so you can expect that we will continue to enhance our Amazon EFS replication feature and add features like you're suggesting. I don't have a timeline to share with you at this point, but definitely we'll take that feedback, and you can expect that we're going to be enhancing our EFS replication. I'm sorry, I'm not able to see everybody, so go ahead, please. Yes.
Just a question. Since EFS and S3 is both storage, is there a easy replication setup you can do between EFS and S3?
Got it. So since the question is, since Amazon EFS and Amazon S3 are both storage services, is there an easy way to sync or replicate your data between EFS and S3? That's a good point. It's a good question as well. You can use AWS Data Sync to move your data between Amazon EFS and Amazon S3. We don't yet have a native technology or a way to move your data from EFS to S3 directly. But I'll take that feedback. I think that is something that we can consider down the road, but I don't have a timeline to share with you. But today, if you want to do it, you could use AWS Data Sync to do it. Yeah, go ahead, please.
In cloud native, we see mostly that the access mode is read-write only more than read-write many. So what are the guidelines that when to use S3 versus to use EFS?
Got it. So the question is about what are the guidelines for when to use Amazon EFS and when to use Amazon S3. So just at a high level, Amazon S3 is object storage. You can still store files in Amazon S3. Amazon EFS is file storage. It's a file system, so it supports file system interactions. It supports file system protocol. It supports NFS. So if you have an application that requires file system access, then EFS is your default choice. If you don't have time to re-architect that application to use the APIs that S3 has, then EFS is your default choice again. Now, in comparison to latencies, you can expect the latencies of EFS are better in comparison to S3. So if your application is latency sensitive and you want to enjoy the 1 millisecond read latency, then I would recommend Amazon EFS as well for that. I mean, there are multiple facets that you can talk about. There's material available for you to discuss, but these are some of the high levels. Go ahead, please.
I have a really similar question, just comparing EFS to EBS. I know it's block storage.
Right.
File storage.
Right. Yeah.
The performance information you shared sounded really good for EFS, so I just wonder,
Yeah.
for file storage, why you would use EBS.
Yeah, great question. So the question is, well, when should I use Amazon EBS and when should I use Amazon EFS? So you said it right. One is block storage, one is file storage, but you can also build your own file system on EBS. With EFS's 1 millisecond read latencies, it becomes very attractive from a latency point of view. So I would recommend using Amazon Elastic File System if you're focused on building serverless applications, if you're focused on building modern applications, if you want to be able to access your file systems from multiple availability zones. Because with EBS, right, we recommend EBS for direct access from EC2 instances. You can read from multiple instances, but if you want to be able to write from multiple instances, then Amazon EFS will provide you that write level consistency. So serverless, being able to access from multiple availability zones, elastic, that's when I would recommend using Amazon EFS. Now, if you have a database applications that is super sensitive to latencies, Amazon EBS all the time. Go ahead, please.
Yeah, so when we use S3, right, so we have in events that can trigger lambdas and as soon as an object has been dropped. So is there similar kind of functionality with EFS as well, whenever a file has been changed or modified, and it can automatically trigger events? This is my first one, and the second one is, does it have any connection with Acquia and all those services like S3 has?
Got it. So I definitely got your second question about Athena. I will repeat that question too. Could you please tell me your first question one more time?
Like whenever we drop an object on S3, right? S3 has the capability to trigger events so that it can
Correct.
trigger
Gotcha.
lambda and then
Yeah.
do the processing.
Yep. Okay, I think I got the question. So the question is, With S3, you can do event-driven programming. When a file or an object is dropped into S3, that can trigger an event, and then based on that event, you can execute a downstream workflow. And then the second question was, is EFS integrated with Athena like the way S3 is? So the answer to both of those questions is no for EFS at this point. So EFS does not yet support event-driven programming. So if you add a file to EFS, it does not trigger an event yet, right? So that's one thing, but thank you for that feedback. I'll take that into consideration. It also does not integrate with Athena either. But you can expect that a lot of the roadmap of EFS is influenced by how S3 does it. We love S3, so down the road you can expect EFS will have enhancements like that. Please go ahead.
Just a follow-up, but from a logging point of view, does it log all these events? Let's say CloudWatch, if there is the file system is feeding in a way?
So EFS has integration with CloudWatch. You can use CloudTrail. To get to the very specific of what's logged, what's not logged, maybe we can have that discussion offline.
Maybe that could be.
Yeah, that's a good point, yes. Please go ahead.
Become more effective to back up an EFS volume than an EBS volume, like for snapshots, as opposed to taking an entire, let's say, for 1 terabyte drive. Are you doing like synthetic polls for EBS and for EFS?
Yeah, so the question is it more effective to back up EFS like the way it is for EBS? Did I get the question right? Okay, great. So EFS is protected using AWS backup. We talked about that, right? Just like the way Amazon EFS replication is continuous, AWS backup also backs up the EFS file system in a forever incremental way. So once we have done that full sync, we're only backing up the differentials. So in a sense, it's a synthetic backup. It's an incremental for full backup.
And it's not pushed off S3 like a snapshot?
No, so you're able to use so is the backup pushed out to S3? That's the question. You're able to access your backups of EFS file systems directly from the AWS backup console as a recovery point. And you can just restore from that recovery point. Like I said, you can restore the entire file system or individual files and folders. Cool. I got time for maybe 2 more questions. Please go ahead.
Following up on the previous question, for cloud-native applications, when you provide read-write many for EFS, it's a POSIX file system. What are the constraints and what do you advise developers? Because basically, how about file locking when there are many items?
Yep, so the question is, for cloud-native applications with single read, multiple writes, what is the recommendation for developers? Are there any best practices, et cetera, right? So that's the question. So EFS is consistent file system. You can have multiple readers, multiple writers. You don't have to worry about is my write consistent? Is my write properly stored or not? When you send a write to Amazon EFS, for standard storage classes, the write is not acknowledged until that write has been written to all the 3 availability zones. So once you get the ACK back, you can be ensured that your data has been written consistently. Okay, 1 more question, please.
This part of it has already been answered, but you took the use case of a CMS, right? If you have in-house built CMS, not Drupal and all, would you recommend using S3 or now NFS for object storage? I mean, not object storage, but
Yeah, so the question is, we talked about content management system. If I have a homegrown content management system, would you recommend EFS or S3? Well, the answer to that is, how is your homegrown content management system accessing the storage? If it's accessing the storage in the format of a file system, then I would highly recommend EFS because you can move that content management system to AWS today without any re-architecture. And then you can benefit from the elasticity. And down the road, if you want to containerize that content management system, that is also fine. This is where I was talking about migration, modernizing, and building. So you are in the migration part of that journey. Awesome, guys. We're running out of time. Thank you so much for staying, and thank you so much for the questions. It was fun.